Okay, so in this video, we're going to talk about how to complete the calculation so that you can ultimately determine the energy content of the food per gram. So we're going to be filling out table 2 using the numbers that you got from table 1 in the previous video. We're going to use the marshmallow example. I'll talk through how to do these calculations with the marshmallow, and then you are in charge of doing the rest of them on your own. Remember, we did not do anything with the kidney bean. So we can cross that out. All right. So again, we're going to be really ultimately working toward the energy content of the food in kilojoules per gram. It's really important that we find the energy content per gram so that we can take something like a 7-gram marshmallow that we burned and compare it to a 1-gram peanut. So if we burn 1 gram of marshmallow or 1 gram of walnut or 1 gram of almond, how much energy can we expect to be released? That's why we find energy per gram. So we're going to get there. We have to find a few things first. So first in table 2, we need to figure out the mass of the water. How are you going to find the mass of the water? Well, we're going to take the mass of the can plus water minus the mass of the empty can. So in this case, I'm going to take 115.1 minus 16.4, and the mass of the water for the marshmallow trial is 98.7. Okay? Change in temperature of the water. That's going to be another simple subtraction calculation where we just take the maximum temperature minus the minimum temperature. 36.5 minus 22.8. That should be a positive value because the temperature went up, and it is 13.7 is our change in temperature. You're going to notice in these equations down here that I use delta T to refer to change in temperature. This is just the Greek symbol delta. In this case, it's used to mean change in. Okay, so final minus initial temp. Change in mass of food. So again, we're going to take our final mass of food and holder minus the initial mass of food and holder. When we do that, so 13.1 minus 13.9, we're going to get a negative number because the food lost mass while it was burning. However, we're just going to write the absolute value down. So I got negative 0.8, but we're just going to write that down as a positive value, 0.8. You can drop the negative sign. We're going to be thinking about energy gained by the water as a positive value rather than the energy lost from the food as a negative. Okay, so those are pretty easy, just subtraction to get the first 3 rows. Now for the last 2, we're going to be plugging in these values into an equation to figure out the energy gained by the water. So to calculate energy gained by the water, you may want to write this down. This looks kind of complicated, but it's really not. We're multiplying 3 numbers and dividing by 1,000. Okay, that's it. 3 numbers we're multiplying together and then divided by 1,000. So what 3 numbers are we going to multiply? We're going to multiply the mass of the water, so 98.7, times the change in temperature of the water, which was for the marshmallow 13.7, times 4.18. I'll explain what that is in a second. Okay. I'm going to hit equals, and then I'm going to divide by 1,000. And I got 5.6, and I'm going to go 5.65. We'll round to 2 decimal places. Okay, so where does this 4.18 come from? So this is a really important constant in science. It's a known value that we use in a lot of different calculations. 4.18 is the specific heat of water. It means that it takes 4.18 joules of energy to heat up 1 gram of water by 1 degree Celsius. That's what these units are here to describe. Okay, so that's the specific heat of water. That's why we include 4.18. The reason we divide by 1,000 is to convert from joules to kilojoules. Okay, so don't worry too much about the units. Just trust me that they cancel out in a way that leaves us with kilojoules. Okay, so now we know how much total energy was gained by the water in the can. The very last step then is we want to know energy per gram. So we have to divide this value, the energy gained by the water, by the change in mass of the food, which we found right here. So for the marshmallow, I'm going to take 5.65, okay, the total energy gained by the water, divided by the change in mass of the food, 0.8, and I get 7.06. 7.06. Oh, one thing I wanted to mention, I did notice that earlier in that video I said that the max temperature of the marshmallow was 34. I was actually going back and watching the video and it got all the way up to 36 and a half. So make sure you have 36 and a half written down for the marshmallow. Okay? So now that you know how to go through and complete the table 2 calculations, your task is to go ahead and do that for the peanut, the almond, the walnut, and the cheese puff. Once you've got this filled out, then I want you to compare, these are the values then, right here, that you're going to see and be talking about for the rest of your conclusions and looking at class data and comparing. Again, is that energy content per gram. So go ahead, start calculating, and let's see if your hypothesis can be accepted or rejected. All right, have fun with those calculations.